even 60. So the chillers, if you size for that, the chillers will be a lot more efficient. And guess what? They'll be cheaper on a dollars per ton basis because the compressor is smaller. So if you look at the kilowatts per ton of the chilled water plant, a typical data center would be, including the pumps and the towers, somewhere around 0.7. And this plant, including pumps and towers, is going to be a little bit under 0.4 kilowatts per ton. So, and then we are going to set up the cooling towers in a way that they can work with the plate frame heat exchanger to do the water side economizer, water side free cooling for the future liquid cooled racks that might come in. So here's just a snapshot of the detailed analysis that we did for SMUD to show them the energy savings. And this is an hourly analysis of the total power draw of the facility, including the IT equipment and UPS losses and everything. And you can see in the winter months, it's flat. That's because the fans are the only thing that are running. And the summer months, we get it bumping up here because the chiller's coming on and off. And we dug into that, zeroed in. Here's the month of July. You can see during July, which is one of the hot months up here, during the day, the chiller's coming on, but at night, we're able to do full economizing. That's because in Sacramento, when it's 100 degrees during the day, or let's say 90 degrees during the day, oftentimes it will go down into the mid-60s at night. You get a nice big temperature swing here, usually 20 to 30 degrees from daytime to nighttime. So we're going to take advantage of that. And then when you dig in, just looking at an individual day, you can see the chiller, it comes on, although not suddenly, it ramps up slowly to the peak in the day, and then is running full out, and then it slowly tapers off and then goes off after the outside air temperature cools down. So pretty straightforward thing. Same thing in October, we still have that happening, but a lot less of it in October. So when we look at the typical data center, the IT equipment is oftentimes, and this would be that PUE of 1.4, 1.5. The IT equipment would be about 70% of the energy use. What we're doing here is trying to squeeze out the chiller and the fan and the electrical losses so that we can get 80, 90% of the electrical use going to the useful work that we're trying to do in a data center. And there's an interesting story. I don't know if anybody is here from SMUD, but they do have this Savings by Design program to encourage commercial and industrial customers to save energy. And it's set up on 8 cents per kilowatt hour saved. We calculated the kilowatt hour saved and came up with our rebate should be over $1 million, right? It was close to $2 million, but the maximum allowable is $150,000. So. If you're in the PG&E territory, they don't have a maximum amount. So you can get bigger rebates in PG&E's territory, but you're paying a much higher price for electricity. So what the folks at SMUD did is trying to be there for their customers. They did give a reduced rate over the long term to ADC. It turns out that they're going to be at 0.773 cents per kilowatt hour, or 7.73 cents per kilowatt hour, and the typical rate's 7.74 or 7.75. So it's a small hundredths of cent difference. But when you look at the amount of power that we're using in a data center, that actually can add up to some good money. Yeah.
Going back to the chiller energy model, the graph you had, did you look at energy or chilled water storage or ice storage to use off-peak power for the cooling?
So the question was, do we look at chilled water storage for off-peak or for failure? We did not look at that for a couple reasons. One is for off-peak, if we take the peak, which is, depending on how you look at it, 6 hours or so, and wanted to do 6 hours of storage, it's well over 1 million gallons. So it's quite a large tank. We did, for redundancy purposes, we are going to have a tank that stores cooling tower makeup water. So that if we lose water and power, We've got water there for the cooling towers, and we've got our generators to run the chiller, but we're not doing that load shifting. Yeah.
Peter, on your flywheel installation, are the UPSs on the background active, or they come on only after the UPS? After the flywheel.
So, sorry.
In other words, taking utility to flywheel UPS, feeding into your clean power grid. On the background, do you have your UPSs on or off?
Bob, I don't know the answer.
I'm confused by the question. I think it's important to understand that these are motor generators.
Yeah.
Oh.
These are high-tech motor generators. Okay?
Yeah. So the wheel's always, it's always spinning, ready to go, and you're just tapping it a little bit to keep it up to speed. It's, you know, the way it's set up. Yeah. In the back, Bob.
Yeah, Peter, your PUE of 1.1, that's on full economizing.
So that's an annual average. That's the only way to look at a PUE.
I don't believe.
Okay.
That's the annualized number, I don't believe.
Okay, fair enough. Anybody, is another question in the back?
I was going to ask what kind of VMS system you customize, you pick the VMS vendor, how you control that?
So we do have certain preferences, and we're leaning towards an ALC, but that's not set yet. So, yeah.
Peter, can you elaborate a little bit more on your fan design? For starters, was your Hunt Air fan bank driven by a variable drive for all the fans to move up and down together, or do they have independent variable speed drives?
So the question is, how are we controlling the fans? Are they moving separately or together? We're going to have them controlled together so that you don't have one bank pushing harder than another into the same room. What will happen is the one that's ramped up will overpressurize the one that's ramped down, and the ones that are ramped down will deadhead. So they all the fans that are serving the same space, if there's no divider walls, they'll all need to be running at the same speed. Yeah.
I suppose the fan vendor is going to solve all those resonance problems that happen when you run at the same speed.
You mean harmonics? Or?
Harmonics.
Yeah, well, you know, there are some issues there, but the VFDs, we're going to be, and we have spec very high-end VFDs that do deal with harmonics, and they're better than some of the older VFDs that have been out there. So we haven't actually seen much of a problem with that. We've done a lot of work in clean room facilities where they'll have even more air running through fans at the same speed. And, you know, more, instead of 1 million, 5 or 10 million CFM, we worked a lot with Intel, and they're seeing that they're not having a problem there. And they're very sensitive to harmonics because they're manufacturing semiconductors. It can be a big problem.
I was actually talking about acoustical resonance.
Yeah. So we do have acoustic consulting on this, and the folks from Hunt Air with their acoustic box have looked at that, and we think we're in good shape. But yeah, I mean, that's definitely an issue. And I think there'll be more like natural frequencies that might set up based on the configuration of the room, and we might need to put certain frequencies off limits on the variable speed drive so that when it goes up and down, it will skip a frequency and not stay there. It will have to go through it, but it won't be able to stay there.
Now, I don't think you showed much about exhaust fans to take the air out of the plenum. Can you speak to that?
Yeah, I mean, there'll be vertical exhaust fans, sort of souped up propeller fans, in essence, on variable speed drives. Pretty much off the shelf, nothing special about it. Yeah. Sure.
Do you have problems with structural engineering requirements? We've seen issues as you're trying to penetrate hotels or other buildings and essentially take down the whole wall structure and take an entire wall out. There are serious structural implications. And did you guys build the seismic zone for stores?
Yeah, so the seismic, or the structural engineer on this project, it was a major goal to make this all work. The side that we have the louvers is the side of the building where the airplanes used to come in, right? So it was already open, the columns weren't right, so there were changes in columns, and there was demolition that was already happening, needed to happen. So it all sort of worked out. It was like new construction. It wasn't that we were taking a full wall that was a tilt-up wall that was a structural wall and popping that down and you know, hoping it all works out. But yeah, it's got steel that holds up the whole structure. Yeah. So maybe, should I end now?
That's great.
Okay, thank you very
Thanks,
much.
Peter.